Hello, hope you're having a nice day. Today I want to talk about engine layouts, displacements, and hopefully clear up some misconceptions surrounding them. Basics first. An internal combustion engine is made up of cylinders. Air and fuel goes in, and then combusts. This creates a force on a piston, which turns the crankshaft, which then sends power to the wheels. Next I want to clear something up. More cylinders doesn't mean more power, or worse fuel economy, or many things to be honest. Having more cylinders can make it easier to make more power, but it doesn't actually have an effect on power output. Most V8s don't make more power than inline 4 specifically because they're a V8. You can see on screen I've got two near enough identical V8s, or a V8 and inline 4, both at around 2 litre, and there's some minor variations there, but you can see how similar they are. The key factor is displacement, or the size of the engine, usually measured in litres or cubic inches on older American cars. This is how much of the air-fuel mixture you can fit in the engine. The larger the engine, the more air and fuel mixture you can fit inside of it, which means that combustion is stronger and you produce more power. Because of this, a 2 litre V8 and a 2 litre inline 4 should make the same sort of power, because they can both make combustion happen equally as strong. There's a little bit of variation due to valve area and friction from more cylinders, but nothing significant. So why do we bother having more cylinders? Surely that's just extra cost and more moving parts that can fail. Well, there's a few reasons, such as with more cylinders you can have more forces cancelling each other out so that the engine can run smoother, but the main reason is because it's easier to make power. For example, let's use the 2 litre V8 and inline 4 again. In the 4-cylinder, you can see there that the cylinders are a bit bigger. In a 2 litre engine, they'd be half a litre big each, whereas in the V8, each cylinder is only a quarter of a litre big. Each individual cylinder is smaller. So the size of a cylinder comes down to bore and stroke. Bore is how wide the piston is, so you can see as I adjust it here, the actual diameter of the piston changes. And stroke is how far up and down it travels. Unfortunately in automation, for whatever reason, adjusting stroke doesn't have a visual change. For now, all you need to understand is that with a larger bore and stroke, the parts in the top and bottom end, that is the valve train and the actual pistons, conrods and crankshafts, become more stressed. So they can't rev as high and still be reliable. I may do a video going into more detail if there's demand. We'll see about that. This is the power equation, torque times RPM divided by 5252. The number you divide by does change depending on the units, but this is just for power as horsepower and torque as pounds-feet. To make more power, you either need more revs or more torque. With more cylinders you can do both easier. More torque comes from combusting more fuel and air, e.g. increasing displacement. Revs meanwhile are basically free to add. It's all about reprogramming an ECU, as long as the components can take the extra stress. So if we're talking about two engines with the same displacement, you can't get more air and fuel in. For example here I've got two 5 litre engines, one's an inline 4, the other is a 5 litre V8. They both make similar amounts of power, but as you can see there, the inline 4 is seriously struggling to rev that high. Meanwhile the V8 can have a much lower bore and stroke to reach the 5 litres, and can make that power without being so stressed. Basically, the bigger the engine is and the more cylinders you have, the lower you can make bore and stroke to reach that displacement and make the engine more reliable as a result. Or if you want to get more power and are revving reliably, you need a bigger engine. Here I've got an inline 4 at 86mm bore and stroke. It's right at the limit of RPM. You can see here its stress indicator is showing that the pistons can take 8,400 RPM. The rev limit is set to 8,400 RPM, so trying to make the engine or produce more torque at a higher RPM, which I could do by adjusting the cam profile, wouldn't really work because eventually I'm just going to be limited by RPM. So what I can do is increase the number of cylinders. It's still an 86 by 86mm bore and stroke, but now it's a 3 litre engine if I turn that inline 4 to an inline 6, and now making almost 250 horsepower as opposed to the 170 horsepower I was producing before. So adding more cylinders effectively well, it does just increase the displacement without adjusting bore and stroke. So the engine is just as reliable as before, but is much bigger. Hopefully that all makes sense. I'm happy to answer questions and things in the comments, whatever. Obviously what I'm saying isn't unique to automation, just the easiest tool to illustrate it. Thank you for watching. Remember to subscribe to Boost and Ethanol for more, leave a like, and yeah, hope you have a nice day. Goodbye.